All right, guys, welcome to the very last set of notes for your middle school career. I'm going to just do official notes on the discriminant. Okay. So we talked about the discriminant a couple times. It popped up in some old tests and whatnot. So the discriminant, maybe if I could learn to spell today. Discriminant is going to be the radicand of the quadratic formula so that's that b squared minus 4ac component. Its value reveals how many times the parabola, which is the graph when you remember graph a quadratic equation, the parabola crosses the x-axis. Okay, so that would be your x-intercepts or roots, solutions. Okay, they all mean the same thing. Okay, so I'm going to draw a little chart. I'm going to do it on the next page just because of room, and then we'll do a couple practice problems, and that will be it. This is probably one of the shorter notes of the year, so I'm just going to give myself some room here. We're going to talk about an equation, and then we're going to talk about the discriminant, we're going to talk about its graph, so we'll just do kind of a small one of it, and then we have the number of real roots. Okay, and we talked about that. The reason why we keep mentioning real is because we're prepping you for, in a couple years, when you're in Algebra 2, or Algebra 2 Trig, you're going to learn about the imaginary number system. Woo! Okay, so let's go through 3 examples. So let's say we have x squared plus 2x plus 5 equals 0. Okay, so we're going to identify a, b, and c. A is 1, b is 2, c is 5. And we're going to just focus in on that b squared minus 4ac. Okay, and we're going to get, let's see, 2 squared minus 4 times 1 times 5, and we're going to get 4 minus 20, and that equals a negative 16. Okay? And when I graph this guy, let's see, we're going to have an axis of symmetry is negative b over 2a. So that's going to give me negative 2, so it's going to give me a negative 1. And so this is going to be my axis of symmetry. When I plug in negative 1 into the formula, I get 1 minus 2 is negative 1 plus 5 is 4. So my vertex is going to be up at 1, 2, 3, 4. So this is going to be my vertex. If I have x is 0, my parabola is going to cross at 5. So basically, I have a parabola that looks like this. So how many real roots are we going to get? We're going to get 0. We noticed that the discriminant was negative. Okay, and so we have no real solutions. Okay, and part of the reason is, if you look at your discriminant, you would have had a negative number under the radical, and that's where we would have no real solutions, because we can't take the square root of a negative yet. Okay, so that's the first one. We've got 3 cases, right? So then the next equation, we have x squared plus 10x plus 25 equals 0. So I identify A, B, and C. A is 1, B is 10, C is 25. We plug it into the radicand under the b squared minus 4ac from this quadratic formula. I'll get it eventually. And so we're going to have 10 squared minus 4 times A times C. So that gives me 100 minus 100, which equals 0. Okay, so let's see what this graph would look like. So let's see, the axis of symmetry would be negative b over 2a, so that's going to give me negative 10 over 2, which is going to give me a negative 5. So that's going to have the axis of symmetry run down through that. Now negative 5 is going to be my x-coordinate of my vertex, and when I put in negative 5, I get 25 minus 50 is negative 25 plus 25 is 0. So I actually get my vertex at negative 5, 0. Now, notice what kind of equation we had. X squared plus 10x plus 25 equals 0. That is a trinomial square. Or a perfect square trinomial. Okay. So then I'd kind of boost it out from there, and my parabola would look something like this. Okay, so how many real roots do we end up with? We have 1. It touches the x-axis 1 time. What do we notice about the discriminant? The discriminant equals 0. Equals 0. We're going to get 1 real solution. And remember, when we take the square root of 0, it's going to give us x equals negative b over 2a. Okay, so it's going to eliminate the rest of the quadratic formula, which means we're going to end up with the vertex. Okay, so I'm going to write it here, trinomial square. Trinomial square. And this is going to lead to the vertex. Okay, let me extend my lines here for our last example. So in this one, we've got 2x squared minus 7x plus 2 equals 0. So I again identify my a, b, and c. A is 2, b is negative 7, c is 2. So remember, when it comes to quadratic formula, you don't have to have your a value, the quadratic coefficient, equal 1. Okay, you can just, whatever you get is what you get. So we're going to substitute it into the radicand of the quadratic formula. So we're going to get negative 7 squared minus 4 times A times C. And that's going to give us 49 minus 16, which is going to give us 33. Okay, so if I graph this guy, actually, let's go down a little bit more. So negative b over 2a would give me negative 3. Oh, negative a negative would give me positive 7 over 2, which would give me 3.5. So my axis of symmetry would be here. Okay, now if I let 0 equal, I'm going to get that my y is going to cross at 2. So let's see here. I have negative 3. That's going to take me too long to figure out. So I'm just going to tell you, because of the 3.5, and then we're going to have a negative number. Yeah, we're going to get a negative number, because that's going to be about between 18 and 32, and then we're going to have minus 21. Yeah, so we're going to end up somewhere around here for my vertex, and then we would kind of go from here. So you notice I'm going to recolor this guy. That's where, for him, that's where it crosses. And again, these numbers aren't accurate, but so you get it. So in this case, we get the discriminant was equal to a positive. I ended up getting 2 real solutions. And the reason why is the square root of 33 is positive. I can do that. I can do that calculation, okay? So I'm going to get a plus or minus number, okay? When I take the square root of that. And then that's the end of it, okay? So those are your 3 cases, no matter what. Let's do some examples real quickly. And the directions, the directions say, let me go back to black. Find the discriminant. Value. Then determine the number of real solutions of the equation. So we've got 4x squared plus 5x equals negative 3. So job 1 is to get everything on the left, 0 on the right. It's got to be in standard form. 4x squared plus 5x plus 3 equals 0. Now identify your a, b, and c. A equals 4, b equals 5, c equals 3. Substitute it into b squared minus 4ac. The reason why I'm repeating it so that I get it logged into my brain. And then I'm going to get, let's see, 5 squared minus 4 times 4a times c. So 4 times 4 times 3. So that gives me 25 minus 48, which equals a negative 23. Okay, so you would conclude there are no real solutions. Let me change that color. real solution. So that's scenario 1. Now sometimes you'll be asked for what is that discriminant, not just how many solutions you'll have. All right, next equation, 2x squared plus 15 plus 11x equals 0. Again, we have an issue with this equation because it's not written in standard form, so we're going to do that. Linear comes after quadratic, and constant comes at the end. Now we identify A, B, and C. A is 2, B is 11, C is 15. We're going to substitute that into the radicand of the quadratic formula. And we're going to get, let's see, 11 squared minus 4 times 2 times 15. So we get 121 minus, let's see, 30, 120. Ooh, look at that. So we get the answer is 1. That's a positive number. So if it's positive, then we say there are 2 real solutions. Oops, that was weird. So I'm going to just add an extra bit right here. So we have a negative discriminant. We have a positive discriminant. And then we have our last example, and then that will conclude our notes for the year. 9x squared minus 30x plus 25 equals 0. So this one's written correctly. So I'm going to identify my A, B, and C. A equals 9, B equals negative 30, and C equals 25. So we've substituted into the radicand of the quadratic formula, b squared minus 4ac, and we're going to get 9 squared minus 4 times, oh, try that again. Going too fast. Not 9. It's negative 30 squared times 4 times 9 times 25. So a negative squared is a positive, so I get 900, and then minus, let's see, 900 equals 0. And so then we would say there is 1 real solution. And then we can say 2 things. We have a 0 discriminant, and we also have a perfect squared trinomial. And that does it, my friends. Trinomial. Good luck. Thank you. Bye-bye now.